in astronomy at Rice University with a courtesy appointment in the electrical and computer engineering, as well as material science and nanoscale engineering. He graduated from Princeton in 1993 with a bachelor's in engineering in mechanical and aerospace engineering, and completed his PhD in physics in 1998 at Stanford. After 2 years as a postdoc at Bell, he came to Rice in 2000 and established a research group looking at the physics of condensed matter systems at the nanoscale. He's also a fellow of the American Physical Society and the American Association for the Advancement of Science, and was named one of Discover Magazine's 20 under 40 in 2008. And finally, he blogs about nanoscale physics at nanoscale.blogspot.com. You should check it out. It's pretty awesome. So, without further ado, we have Doug.
Knock it off, Mark. Thank you, everyone. I'm very happy to thank the organizers and thank all of you for turning out. I'm glad I'm going last because that's giving me the chance to drink more heavily, and thus anything I say will be funnier. So when I was a grad student, one of my roommates, and this does actually have some relevance to this talk, one of my roommates was also a physics grad student, but when we would go to parties, he would masquerade and claim that he was a comparative literature graduate student in an effort to meet the ladies. And one of his stock complete sort of things to say was he had a phrase that he liked. It was something that could be a textual failure, but a metatextual success. And of course everyone says, what the hell does that mean? He says, well, an example would be a boring paragraph about boredom. Because it's a failure as a text, but in some meta level it's good. So this is kind of a meta talk, right? Because I was asked to talk to a general audience about presenting science to a general audience. So I hope this is not a textual failure. And the other part of my title comes from when I was a grad student. Again, I was at a little Bay Area mini conference, and it was late in the day, and a speaker got up and gave basically no introduction at all, and just delved directly into some incredibly arcane series of compounds that was very complicated. And Bob Laughlin, who went on to win the Nobel Prize, but is famous for being outspoken, he got up in the middle of this guy's talk, like 3 or 4 minutes into the talk, and just stood up and raised his hand. And the guy was like, kind of stumbled to a halt. Was like, yes, can I? And he didn't know who the guy was. Can I help you? It's late. We're all tired. Why should any of us care about anything you're saying? And so that has stuck with me. That was like 20 years ago, and so that's really stuck with me, which is why I try to think really hard when I plan talks to a general audience. So I'm going to talk about presenting science to a general audience. Now, why should people care about science? Again, this is kind of like a cheap laugh line, right? I'm preaching to the choir here. You wouldn't be here if you didn't care about science. I mean, basically, science followed by engineering has created the whole modern world in a very real sense. I mean, it's given us, medicine and DNA and MRI machines and, come on, there you go, the food pyramid. I mean, who doesn't want like the food pyramid? Satellites and iDevices and computers and that's actually a brewery. You can't really tell in this screen. I was really looking for a great picture of a distillery, but I failed. And it's given us, factories and cars and airplanes and nuclear power plants or power plants of all kinds and lolcats. I mean, so science obviously is a happy thing, but again, in a bigger picture way, why should scientists try to explain what they do? Well, I'll try not to get too serious, but the fact is that a lot of the money we get to do what we do comes from you. I mean, not too much. We can. The entire NSF annual budget is sort of 1% of the DoD budget, right? So this is it's always interesting to think about these things. But the point is that this is a Roosevelt quote. We actually need an informed populace, right? We need people to be able to tell shit from shinola, okay? People need to be able to tell the difference between stuff that's legit and real, and stuff that's, ooh, weird crystal magic and wearing magnets on my wrist will make my arthritis go away. We need an informed no offense. So we need an informed populace. So, oh, you really can't read this at all. So this is getting there. This is from PhD Comics. If you're not familiar with PhD Comics, you should read it. This is the science news cycle. So up here, hang on. Here's the grad student who basically says A is correlated with B at a level of like maybe 56%, given a whole bunch of other qualifiers. And so the university PR office is like, there's a link between A and B. And then news organizations are like, A causes B. And if you get down here, you know, what you don't know about A and B can kill you, says CNN. And then, you know, by the time you get back, like grandma here is wearing the aluminum foil hat on her head because she's worried about the effects of B on her A. So, you know, part of the issue is if we as scientists don't do an okay job explaining what the hell we're doing, who else is going to do it? I mean, this is not meant as a slam on science journalists. There are some extremely good science journalists. But this is a really hard job. And scientists, sort of by definition, kind of know their subject better than reporters. And so we have a certain responsibility to talk about our stuff. Now, scientists have an image problem, Nerd Night notwithstanding. What do I mean by this? Well, if you go to Google, you know, if you really want to get the zeitgeist, you go to Google and you start typing and you see what comes up. And so now I don't know if this is still true, but this was true a couple of weeks ago. So if you type scientists are, the autocomplete is liars, liberal, stupid. By the way, the fourth one was scientists are creating animal-human hybrids. Which I have a feeling must have to do with certain news stories, so I got rid of that one.
That's just because you didn't capitalize scientists.
Very good. So, okay, let's focus down a little more narrowly than scientists. Let's talk about physicists. So I'm a physicist, but as you heard in the intro, in the wayward days of my youth, I was an engineer. In my salad days, and so some of my friends say I turned toward the dark side, some of my friends say I turned away from the dark side, just depends who you talk to. But, well, you know, what do people think of when they think of a physicist? And here's the hint. There's a reason my old roommate used to pretend to be a competent grad student. Okay, so what image does physicist conjure in the average person's mind? Again, we turn to Google image search. So the first image that turns up, hey, that's not bad. I can live with that. Second image that turns up, all right. A little more modern, Stephen Hawking, that's good, that's good. You know, one of the other images that turns up prominently early on, it's Professor Doofenshmirtz from Phineas and Ferb. If you don't have kids, you may not know this, or if you don't watch Disney Channel, you may not know this. All right, and then of course, Sheldon Cooper from Big Bang Theory. And the really frustrating thing about Big Bang Theory is that most of us who've gone through the physics PhD process do actually know people kind of like this, but they are not the rule. And so, you know, again, the microcosm here, so just from my own personal example, when I tell people I'm a physicist, what's the standard reaction I get? Well, I hated physics in high school or college. That's a good one. Or the equally useful, wow, you must be really smart. Flattering but not accurate. And again, if we do the Google autocomplete thing, we get physicists are, you can't really see it, arrogant, stupid, and crazy. So, you know.
Most objectionable than the scientist one.
Well, I don't know. Stupid is still in there. That's not so great. Or liars isn't in there. I'll grade you that. All right. So, you know, why is this okay? I mean, if I don't know Shakespeare's plays, and I'm viewed as some sort of uncultured slob, right? But somehow it's socially acceptable to think that magnets can cure your arthritis. Why is it okay to be scientifically ignorant? What's the deal? And I'll say a little more about this in a second, but and I won't be too long. But I think one of the big issues, and you all appreciate it, science has a high cost of entry, right? You know, if you really want to, it's a very hierarchical discipline. Physics in particular, but other ones too. And if you just want to get down to the really nitty-gritty details, it just takes forever to learn how to do all this stuff. And you know, that's why science can seem kind of mysterious. And I will say, people consciously associate science with bad things and their fears, because you hear about Chernobyl, and you hear about H1N1 is going to wipe us all out, or or whatever. And then, but science's benefits are sort of all around us, but they're so all around us they kind of fade into the background, right? You don't even think about the amazing science that went into producing the chip inside your iPhone. And I do think there is, in the US, we do have some cultural nervousness about people who claim to know the truth with a capital T, or discomfort with book learning, you know? That's maybe a Texas thing. I don't trust none of that there, book learning. I'm not from Texas, you can tell. So, one of that first issue, the high cost of entry, you know, science is hard. We know this because The Onion told us that. National Science Foundation has concluded, science hard. With the help of graphic. So, one, you know, and again, as Professor Boyd knows well, you know, many really important and interesting problems are actually complicated. And you can't summarize them in a 10-word sentence or a 30-second elevator pitch because they're complicated. And that's just the way the world is sometimes. And the other issue is, again, you know, if you're trying to communicate science to a big audience, you know, everyday people cannot be expected to know all the details. All right? You have to be able to use analogies. And analogies are fine, except when they don't work very well. Now, this is actually a clip, but you won't be able to hear the audio, I'm pretty sure. I don't know, is the audio turned up on the laptop?
I mean, if you get really close to the laptop, you'll be able to hear it.
So,
don't everyone like...
And then Jake can reenact it.
Okay.
We're really close to the laptop.
Trying.
Just bring the mic to the laptop.
Oh, it's not even going to play.
That would actually work.
That sucks. All right. It's the clip from Futurama where...
Get some nasty.
I will say, Fry basically says to Leela, well, sometimes, you know, they on this TV show, Star Trek, you know, there's usually some really complicated solution, but they come up with some sort of half-baked analogy that seems to make it all very simple. And they made some really complicated, crazy solution, and then Bender says, oh, like filling a balloon with too much air. Like, oh, it's so simple. Anyway, it loses something in translation.
I didn't want to leave them either, Fry. But what were we supposed to do?
Well, usually on the show, someone would come up with a complicated plan, then explain it with a simple analogy.
If we can reroute engine power through the primary weapons and reconfigure them to Melvar's frequency, that should overload his electroquantum structure.
Like putting too much air in a balloon.
Of course! It's so simple!
Now, physics in particular, and solid-state physics, which is sort of my area, we've got a bit of an issue because some fields really have a natural appeal, right? You know, there's a joke. The reason the NIH has such a big budget is because every member of Congress has either breasts or a prostate, right? I mean, everyone appreciates the benefits of medical research. You don't need to be an expert at biology to understand the benefits of medical research. Similarly, you know, if I show you pictures of galaxies, everybody who is not an astrophysicist is like, that is the coolest damn thing. I sometimes wish I was an astrophysicist. Whereas the astrophysicists are like, yeah, I know it's cool. Similarly, you know, because it's got a broad appeal, there have been some fantastic popularizers of astronomy and astrophysics, right? Carl Sagan, Neil deGrasse Tyson. I hope you're all going to watch the new version of Cosmos when it comes on.
Yeah!
Yeah, but he's got an awesome waistcoat. And then, of course, there's the high energy community. The high energy community, even though what they do is ridiculously complicated and hugely expensive, they've got the advantage that they can claim that they are telling you about the origins of the universe, right? This is the nature of existence. I mean, that's kind of a pretty good hook. And so, you know, and then you got people like Brian Greene and this guy, this idiot, I mean, Michio Kaku, who have again been very effective at showing up on the Discovery Channel or on PBS and trying to sell us on the profundity of what they're doing, right? Now, my area is condensed matter physics. I promise I only have like 2 not even technical slides, but just to give you an idea of the kind of stuff I do. So what is condensed matter physics? Well, it's basically, you know, the properties of liquids and solids, everyday stuff, right? It's the stuff all around you. There are actually hidden in here, and this is one thing that I think is cool, there are really some deep ideas. There are ideas about symmetries, like superspaces, phases, what do we mean by phases of matter, right? quantum physics is in there. We can worry about the arrow of time. Why is the past different from the future? And one of the big things about condensed matter physics is this idea of emergent properties. More is different. This is a line from an article by Phil Anderson, another Nobel Prize winner, back in '72. Instead of more is better, the idea is more is different. What do I mean by that? Well, here's one water molecule. Okay, you got your oxygen, your two hydrogens. It's pretty simple. It's pretty boring. One water molecule is not wet. Right? That's not you can't sensibly describe one of anything as wet. But if I take 10 to the 24 of them, so a million of them, and put them all together, I get this, right? Or, in fact, if I cool this down, as we learned this past week, I get this, right? You get, or not. You get spontaneously, amazing symmetries that fall out from the collective behavior of a zillion of these. So, that's the fun stuff behind condensed matter. Unfortunately, it's hard to cast a big, broad public appeal with that. Let me just give you a tiny flavor of two things that I do. Okay. So I work on nanoscale science, and basically the idea is how do really small systems work. Let me give you one example. So, the crossover between like exotic quantum stuff, which is very neat, and boring classical things, which we all know from our daily experience, right? So, if I want to worry about this is the hydrogen. These are the orbitals of hydrogen. You may have learned this in chemistry back in high school. You get your s orbitals and your p orbitals and your d orbitals and all that stuff. The point is that if I worry about electrons on the scale of one atom, I really need quantum mechanics in order to get all these funky shapes and understand what's going on. But on the other hand, if I take a battery and hook it up to a light bulb, the electrons flow through this thing, the light bulb glows, and I don't have to worry about quantum mechanics at all. Well, now you do, but for the most part, you don't. And so, on the scale of 0.3 nanometers, the electrons are wave-like. There's all kinds of exotic interference stuff that gives you these funky shapes. But on length scales like a centimeter, you don't see any evidence of all this quantum stuff. So one of the things I study and have studied is how do you get from here to here? Like, where's the crossover? Why does the quantumness go away? A second thing, experiments can actually look at this. That's the point. I'm an experimentalist, which means my grad students do all the work. As opposed to if I was a theorist, in which case my postdoc would do all the work. Okay, the other thing that I find interesting is this issue of heating and irreversibility. What do I mean by that? Okay, here's a filament in what used to be called a light bulb. You may have heard of them. They're going away. And so what's going on here? Well, somehow electrical energy from the wall or from a battery or something is eventually turning into heat. It's turning into the disorganized vibrations of the metal atoms in here. And in fact, they're getting so hot that they are somehow magically radiating light. Right? Okay, but again, there's something like a million atoms in this thing. What happens? How does that work if I've got such a small system that I can see the atoms, that I've got a very tiny number of atoms there? And so, what if we have very few atoms to play with? What does heating even mean? What does temperature even mean if I've got 1 of something or 15 of something? Right? So these are the kinds of things that I work on. So with that, I'll just try and give you a take-home message here. Science is good. If you're at this thing and you don't know what XKCD is, I don't know what to do with you. Scientists have to get out there, right? And you have to actually explain to people what you do. And you need to put a human face on this stuff. I mean, the point is science it can be fun, exciting. It's a very human thing, right? There's stories connected, anecdotes connected with all the big discoveries, and those are fun. People like stories. Within science, we really need to appreciate the people who excel at public outreach. So Carl Sagan caught flack. I mean, he was a very good planetary scientist. He was a serious, credentialed person, but he caught flack from his colleagues for doing that stuff. And so we need to appreciate the people who do good jobs at this stuff. Bill Nye. Though technically he's an engineer, actually. And don't reward the people who just spout BS. Okay? He's never going to watch this. And again, just in the end, in my own area, condensed matter physics, there's really a crying need for a Carl Sagan. There's a need for somebody who can really hit the highlights of this stuff at a level where people understand why it's important and what it at least sort of what it means. And the problem is it's just hard. It's an uphill slog. Anyway, with that, I'd like to thank you again for your attention. I'm happy to take any questions.
So how does someone at this level understand science?
Well, it's not clear that not everybody has to understand science, and I think I would argue if you're, if you're at a subsistence level and you're really worried about where your next meal is coming from, you probably have bigger priorities. But on the other hand, how does someone like that learn about science? I mean, it's very hard. If people don't have exposure to education and they're really in a hand-to-mouth existence, it's tough. But I think these days, with if the person living hand-to-mouth in Guatemala also has a cell phone, I mean, there's lots of people, lots of places in undeveloped countries that have cell phones and stuff. It would just be nice if someone at some point explained to them a little bit about how those things worked. There was a hand over here, yeah. Regardless of my fondness or non-fondness of string theory, I'm really not fond of Michio Kaku. Because I think sometimes he really crosses the line into sensationalizing stuff. I mean, yeah. I mean, there's a difference between science and science fiction, and I'm a huge science fiction fan. But like, I'm annoyed at that. I'm as annoyed at that as I am with allegedly scientific, documentary programming having ancient aliens on it, right? Like that just pisses me off. So, yeah.
I just want to follow up to his question. So, do you think that there's like basically a ceiling for the average person on what they can understand science-wise? And if so, where is that?
That's a really good question. Well, in some practical sense, sure, there's a ceiling in that if I have some really obscure mathematical result that you need to understand, like, let me give you an example, right? If you want to understand how Andrew Wiles proved Fermat's last theorem and really understand it, that's very hard, right?
Prove it in a way that Fermat couldn't have using like
that's true.
Complex computer stuff.
Right. Well, elliptic integrals and elliptic curves and all kinds of crazy stuff. But the point is that, like, you can kind of appreciate, you as a layperson can appreciate what the theorem said, and that someone proved it, and that it took several hundred years for someone to do it, right? But yeah, really understanding the details is hard. So I think there's a lot of things where, like, people can appreciate the big picture and the big story, but they're, people hear on the radio today about a new paper about how you can basically take some cells, and if you expose them to an acid environment, they can kind of act like stem cells now, right? And like, okay, I don't know jack about cell biology, but I kind of understand that on some level, right? And so I mean, there certainly is a hard ceiling on technical details for the average person. And I mean, the problem is that, if we basically decide it's not even worth teaching people Algebra 2, then that puts a pretty low bar on some things. I mean, frankly, in some sense, if you really want to make a huge difference to society in the US, you really worry about numeracy as much as you worry about literacy. I mean, I think if people understood compound interest, really understood it, they wouldn't get into thousands of dollars into credit card debt. Multiple hands. Yes?
Do you think that with modern media being the way it is, and between the internet and 24-hour news cycle, that's actually led to an increase in understanding in the general population, or a greater increase in insular societies that only want to hear what they want to hear?
That's a really good question. So certainly on the political front, I think it makes it very easy to only read what you want to read. There's more knowledge accessible now. So just, you look at the many people who go and download free lectures off of MIT's OpenCourseWare and things like that, and that's all good. I do worry that, it gives a giant platform to just about anybody, though, which can be good or bad, right? Because again, sometimes it's hard to tell the difference between, there can be things where if you're a layperson, you can't tell the difference between whether something's real or whether something's just kind of sketchy. And I don't know, I think there certainly are communities, in fact there are kind of communities of people who have what I would call peculiar scientific beliefs, who now can find each other and be buds and hang out. I mean, believe it or not, there is an active geocentrism group of people out there. For those of you, they think the sun goes around the Earth, right? And these people have now found each other on the internet, and they've got like a discussion thing going. It's very funky. So I don't know if this is a good thing or a bad thing, but I think on balance it's good. I think freely available information is a happy thing. Yeah.
You mentioned earlier, the
internet reinforces extant tendencies.
Problem in explaining, the quantum model of hydrogen. What is a good way to dumb that down?
What?
That's actually a question I get quite a bit.
But that's my point. It's like the internet gives you choices, so you're going to go on to something that's good or something like. So you're going to look for things that interest you or look for things that reinforce your existing opinions. So if you're open, you're going to find things that expand your consciousness. If you're closed, you're going to find things that reinforce that.
But it would take several minutes, and it's not a 30-second thing.
Well, then take several minutes. Do it.
I need pictures too. I don't have to make pictures.
No, you don't. You're just a thought.
Today I read an article that mentioned Texas schools still teaching evolution, and not teaching evolution and teaching creationism. And one of the politicians said that it's okay because evolution is just a theory. How can you end up explaining to people that a theory and a scientific theory are different things?
Those gravity bitches.
Yeah. What she said. No. Right. I mean, yeah. This is the other. I could have touched on this, but the general populace and scientists use vocabulary differently. My favorite example of this is, I'm old enough to remember congressional briefings before the year 2000 turnover, and there was a guy testifying before a congressional subcommittee, and he said the risk of accidental nuclear war due to the Y2K problem was low. And of course, all of the congresspeople's eyes bug out of their heads, like, low? And it better be freaking zero. So when scientists meant low, he meant like really, low, but vanishingly small. But yeah, so it's tough. I mean, this is again something that we as scientists have to try and do a better job of educating people about. The interface between science and religion is particularly tricky because sort of a cornerstone of religion is the idea of taking things on faith. And so it makes it very, very tricky to, if someone is basically committed to saying, well, I understand what you're saying, but my faith tells me this other thing. There's not a lot you can do, But I agree, like having people understand the difference between a theory and a wild-ass guess would be really nice.
What can we do as lay people to turn our friends and peers onto science?
Take them here and buy them drinks. No. I actually think some of the stuff on social media. There's a website called I Fucking Love Science. I don't have like completely unalloyed love of that, but it's awfully good most of the time. And so I mean, like people like learning little factoids and things. I mean, but it's tricky. I mean, I think just conveying your enthusiasm and saying, "Hey, listen, you see this?" And I don't want to encourage people to be those annoying people that send those, forward. But I mean, if you see something cool, tell people about it. I mean, that's a big plus.
So you just mentioned I fucking love science, but it seems like the internet has kind of gone this like trend where they're just fetishizing science. So it seems like it's always people are just taking things they see just because it mentions the word science automatically fact, but it's very dogmatic, taken on faith kind of thing rather than actual understanding. Would you say that's a good thing?
Well, I think this is a tricky thing, right? So in some naive way, I'd love it if everyone just took scientists' words for things, but that's exactly antithetical to the way science works, right? The whole point of science is you should be skeptical. And you should ask questions like, well, how do you know that? How do you know that's so? So I have mixed feelings about that.
It seems like a lot of kind of thinking secularism is a new form of religion.
Right.
Okay, you and then you.
When I was teaching science in middle school, I was trying to teach my students about weather and such, right? And so I'd ask them, where does wind come from? And I get these amazingly weird answers, right? And so this is kind of a little experiment. I walked across the hall and asked the English department. And I got very similar, you know, I mean, they're not quite as stupid. And so, I mean, I tried the same thing with, you know, asking them, you know, well, what is density? And they couldn't tell me what density was. These were all people who had college degrees, you know, who were smart people. So, I mean, when the bar is so low that even people who have a college degree don't know the basics of middle school science, I mean, we're in a really difficult situation.
Well, that's sort of what I meant about if I don't know who Shakespeare is, I'm some kind of an idiot. But you know, if people don't know why ice floats in a glass of water, you know, that's perfectly fine, right? I mean, I don't know how to fix that. I wish I did.
So I'm curious what your personal thoughts are on the direct debate the famous Bill Nye creationism debate coming up in a few days. What are your thoughts on actually directly challenging somebody who is a faith-based Christian?
Well, I think so. You know, yeah. The question was basically, what do I think about the upcoming, you know, Bill Nye debate with the creationists and the head of the Creation Museum, and whether it's a good idea to have head-to-head public debates. I mean, I think it could be effective if done right, but if it's just going to be people talking past each other, it's kind of pointless. If it gives people a platform to spread misinformation that they otherwise wouldn't have had, I don't feel good about that. I mean, let me flip it around though. I mean, the one that really makes me uncomfortable is Richard Dawkins. Is a very, very, I mean, you could describe Dawkins as sort of a proselytizing atheist, right? I mean, he's, you know, you can disagree with applying religious faith to scientific problems without publicly confronting religious people and telling them they're idiots for believing their faith, right? I mean, you know, in fact, the same roommate who used to masquerade as a comp lit grad student, he's actually a quite religious guy, and he had what I thought was a very good attitude, which was, look, I'm a science person. I'm going to assume as my baseline assumption that direct divine intervention is not responsible for the things I see in the world, right? Because if I assume that, you know, the universe was created 15 minutes ago with you already sitting here, and the light already on its way from distant stars, you know, if I make assumptions like that, and I can say I believe that because God, you know, then I'm done asking questions, right? So I mean, it's possible to have, you know, having a debate, if it's just going to be two people basically yelling across each other, you know, I mean, I don't think anyone's mind is going to be changed by that debate, which is why, like, I appreciate Bill Nye. Bill Nye's attitude, I think, is ignoring people who want to do this stuff is not working because they're not going away. But I'm not sure that this is going to be a productive thing.
So, with the sensationalist media that we have that's going to fixate on every end-of-the-world outlier, how do we offset that and bring the truth of what the science is actually saying to the public eye?
Boy, that's tough. I will say, I think it's the responsibility of scientists when they talk to the media to be careful what they say, and to, you know, I very rarely put out press releases about my stuff, but when I do, I really, you know, actually Rice has a really great press office. I sit down with these folks, and I really make sure that the press release doesn't say anything that's bad, or so oversimplified that it's, you know, misleading. And I think some people aren't, you know, you can't always control what reporters are going to say. But yeah, I mean, it's important to work at that. I mean, the real problem, like medical research is the one where it's really tough because, you know, eggs are good for you. Eggs are going to kill you. You know, nuts are safe to eat. Nuts are full of fat. I mean, you know, so, you know, that's the one because, you know, you'll have some poorly done you'll have some study that's poorly reported on where it'll like have 11 people in it, and someone will try and make some huge generalization based on that. So, I don't know. It's tough.